Hello everyone, welcome back to my YouTube channel. I am Suhas PR studying in Sri Venkateshwara College of Engineering. Today we are going to discuss few topics on discrete mathematics. Introduction to logic in mathematics. Logic is the study of reasoning and argumentation. It helps us to analyze arguments, to identify valid conclusions, and to avoid fallacious reasoning. Propositional logic. Propositional logic is a fundamental area of mathematical logic that deals with propositions, which are declarative sentences that can be either true or false. Firstly, propositions. These are the declarative sentences with truth values. Connectives, operators that combine propositions. Truth tables are the representation of truth values. Logical equivalence. When propositions have the same truth values, logical equivalence occurs. Logical implication means one proposition implies another. By analyzing and manipulating these propositions, we can develop formal systems for reasoning and proving mathematical theorems. This foundation is crucial for understanding and more advanced logic concepts and applications in various fields. Logical connectives. These are the building blocks of propositional logic. They allow us to combine propositions into more complex statements. First one, conjunction. The conjunction of two propositions is true if only if both propositions are true. Disjunction. The disjunction of two propositions is true if at least one of the propositions is true. Negation. The negation of a proposition is true if the proposition is false and vice versa. Conditional. The conditional of two propositions is true unless the first proposition is true and the second proposition is false. Biconditional. The biconditional of two propositions is true if both propositions have the same truth value. Next, truth tables. Truth tables are a visual representation of the truth values of logical statements. They show how the truth value of a complex statement depends on the truth values of its individual components. Truth value assignment. Each row in truth table represents a possible combination of truth values for the variables involved. Evaluating statements. By following the rules of logic, you can determine the truth value of a complex statement for each row. Logical equivalence. Two logical statements are logically equivalent if they have the same truth value for all possible truth assignments on their variables. Logical equivalence is denoted by the symbol as shown here. It means P and Q have the same truth value. Logical equivalence allows us to simplify complex logical statements and to prove logical theorems. Logical implication. Logical implication refers to a conditional statement of the form if P then Q. It is denoted by P implies Q. It states that if the antecedent P is true, then the consequent Q must also be true. The truth table of implication shows that P implies Q is false only when the P is true and Q is false. It is true in all other cases including when P is false. Examples of logical implication can be found in everyday language and in mathematics. For instance, if it is raining, then the ground is wet. It is a logical implication. Logical inference. It is the process of deriving new conclusions from existing statements or premises. This is a fundamental aspect of reasoning in mathematics. First one, modus ponens. If P then Q, P is true, therefore Q is true. Modus tollens states that if P then Q, Q is false, therefore P is false. Hypothetical syllogism states that if P then Q, if Q then R, therefore if P then R. Disjunctive syllogism states that P or Q, where P is false, therefore Q is true. These are some examples of common inference rules used in formal logic. Predicate logic, variables and predicates. Predicate logic uses variables to represent objects and predicates to describe their properties. For example, the predicate P of x could mean x is a prime number. Quantifiers. Quantifiers are used to express the scope of predicates. The universal quantifier indicates that the statement holds for all elements in a set. The existential quantifier indicates that the statement holds for at least one element in a set. Formulas. Predicate logic formulas are built from predicates, variables, quantifiers, and logical connectives. They can express complex relationships between objects and their properties. Applications. Predicate logic is widely used in mathematics, computer science, and AI. It provides a framework for formalizing and reasoning about complex systems and concepts. Quantifiers. These are the symbols used in predicate logic to express the quantity of elements that satisfy a particular predicate. Universal quantifier. It means for all or for every. Existential quantifier. It means there exist or for some. Bounded quantifiers restrict the domain of quantification to a specific set. Quantifiers are essential for expressing complex mathematical statements and reasoning about the relationship between variables and predicates. Applications of logic in mathematics. Logic is essential for reasoning and proving theorems in various branches of mathematics. Set theory. Logic helps define sets, subsets, and operations. Number theory. Logic used to prove properties of numbers. Topology. Logic is used to prove continuity. Algebra. Logic is used to prove equations. Mathematical logic provides a rigorous framework for formalizing and analyzing mathematical arguments. It's widely used in computer science, artificial intelligence, and philosophy. Thank you for watching my video. If you liked the video, then please do like, share, and subscribe. Thank you.